A snack company sells bulk nuts, fruits, and granola. The company plans to offer a new trail mix for $4.07 per pound that is composed of granola, peanuts, and raisins. There will be twice as many pounds of peanuts in the new trail mix as raisins. When sold separately, granola sells for $5.99 per pound, peanuts sell for $2.99 per pound, and raisins sell for $3.99 per pound. How many pounds of each ingredient are in 100 pounds of the new trail mix? Write a system of three linear equations to represent the situation and a matrix equation to represent the system. Represent and solve the system using matrices with technology. Okay, so it's asking us here in our question how many pounds of each ingredient are in this 100 pounds of the new trail mix. And so our ingredients are granola, peanuts, and raisins. So we want to know how many pounds of each. Let's go ahead and define those variables. So just for simplicity, let's call the pounds of granola G, the pounds of peanuts P, and the pounds of raisins R for this 100 pounds of new trail mix. So using that, then let's go ahead and write our equation. So as it said here, we know it's going to be 100 pounds total. And so the amount of pounds of each should add to 100. So we could say G plus P plus R equals 100. And then it also tells us that there are twice as many pounds of peanuts in the new trail mix as raisins. And so if there's twice as many peanuts, then that means the number of peanuts. Well, for the raisins to equal that, we're going to have to double the raisins since there's so many more peanuts. And let's also look at how we could use this price for a third equation. And so we know the price per pound of each ingredient, and then, we know the total once it's combined what it's going to be. And so using that, then we could say, well, if it was $5.99 for every pound of granola, so multiplying by each pound, and then $2.99 per the pounds of peanuts, and then $3.99 per the pounds of raisins, how does that relate then to what it should be as a total for all of them? So it should equal $4.07 for the total number of pounds of all these added together. Well, we know all of those added together is 100. So if we multiply that by 100, then we should get, how much these prices and with the number of pounds of each, how much that should add up to. And so let's go ahead and rewrite these all in standard form. And so rewriting this, then since they are, in two of them we already have the G, P, and R in order. They're already in standard form. We can leave those be, and then they have the constant on the other side. The second one we will have to rewrite though. Okay, so I've gone ahead and I've rewritten, and then just note here that we can go ahead and multiply the two constants on the other side. So 4 times 100 just equals 407. And then for the middle equation, then we don't have a G term, and so we can go ahead and just put 0G there. And then we have one P term, and then we also have a 2R, but it's on the other side. So let's move that over by subtracting 2R on each side. So minus 2R, and then equals, well, 2R minus 2R is 0. And so using that, then we can go ahead and make our matrix. Coefficients of the first equation are 1, 1, and 1. The second one, 0, 1, and -2. And then third one, each of these numbers in front here. Times the variables in order, G, P, and R, equals the three constants, 100, 0, 407. And so if we call this left matrix matrix A and the right matrix matrix B, then all we need to do to solve this is multiply matrix B on the left by the inverse of matrix A, and we'll get our answers. So let's go ahead and do that in the calculator. First, go to the matrix menu by pressing second matrix, and then go to edit, and we'll put in first our coefficient matrix, which is the 3 by 3 matrix on the left. So 3 by 3, and then we'll go ahead and enter in the numbers, just pressing enter in between each entry and making sure that it matches exactly. Okay, now that we have that matrix, let's go again to second matrix and then go to edit, and this time to matrix B, and we'll put in our constant matrix, which is a 3 by 1 matrix. So now we can go to our main screen, and we'll go ahead and we want the matrix A, so go to the matrix menu, press A, and then the inverse of that, so x to the -1, times matrix B. So go again to second matrix and then go to B and press enter, and then press enter. And so this is our answer. So we know that the pounds of granola are 28 pounds, the pounds of peanuts 48, and then the pounds of raisins 24. And so let's go ahead and summarize our answer. To find the variables, let G be the amount in pounds of granolas in 100 pounds of the new trail mix. Let P be the amount in pounds of peanuts in 100 pounds of the new trail mix. Let R be the amount in pounds of raisins in the 100 pounds of the new trail mix. Write a system of linear equations in standard form that represents the situation. G plus P plus R equals 100. P equals 2R, 5 and 99 hundredths G, plus 2 and 99 hundredths P, plus 3 and 99 hundredths R equals 4 and 7 hundredths times 100 becomes G plus P plus R equals 100. 0G plus P minus 2R equals 0. 5 and 99 hundredths G plus 2 and 99 hundredths P plus 3 and 99 hundredths R equals 407. Write a matrix equation that represents this system. 1, 0, 5 and 99 hundredths, 1, 1, 2 and 99 hundredths, 1, negative 2, 3 and 99 hundredths, times GPR equals 100, 0, 407. To represent the system using technology, enter a 3 by 3 matrix A with entries equal to the coefficient matrix, and a 3 by 1 matrix B with entries equal to the constant matrix. To solve the system using technology, multiply the inverse of matrix A by matrix B. The inverse of matrix A times B equals 28, 48, 24. There are 28 pounds of granola, 48 pounds of peanuts, and 24 pounds of raisins in 100 pounds of the new trail mix.